Well, hello, good afternoon, everybody. You know, the internet has come a really long way. And if you think about it, it took us some 40 years to connect every single computer on the planet. But we are where we are today, billions of computers connected. And, you know, once we're done with the fixed internet, we're like, okay, what's next? So we started to connect mobiles, and we built the mobile internet. And you know this as 2G, 3G, 4G, and now 5G. And once that was done, we're like, okay, what else can we connect? And we started to connect things. Think of sensors and actuators all around the world, trillions of devices, and we created the Things Internet, or the Internet of Things as we know it. Now, in 2014, I was kind of thinking, what's going to be the next internet after the Internet of Things? And the inspiration came with the Ebola crisis. And actually, it's very telling that we are now in a very similar crisis again. But back then, it was the Ebola crisis, which was ravaging Africa. And King's College doctors were leading the response of the United Kingdom in Sierra Leone. And the response we got from our doctors down there was very clear. They were saying, look, guys, we really need medical skills. And nobody dared to travel down there because everybody felt it is just really too dangerous. And I thought, you know, why don't we combine really powerful networks, put a little bit of edge robotics and AI in the mix, which was very popular back then already, and we built something which would allow us to virtualize medical skills. Nothing sophisticated, you know, just palpation, you know, you're taking the temperature, just a human being with a human being. And once this is up and running, I thought we could beam in essentially medical skills from anywhere in the world to Sierra Leone to help. And we were crunching this concept, and we realized actually, you know, we can do so much more with that. And, you know, once up and running, we could have people teaching other people how to dance, how to paint, you know, how to repair an engine. And, you know, I thought, you know, once this is up and running, we could literally democratize the way skills, physical skills, are being transmitted over the internet. And I gave it a name, and I called it the Internet of Skills. And we had a lot of people laughing at us back then, but it's now really taken momentum. And the reason they were laughing at us is because they're saying, Mischa, it exists already. You know, we do have an internet like that already. And what they were referring to was the Industry 4.0 movement. So you see that in the top left corner there, where you see the an Industry 4.0 slide. This is all about factory automation, loads of sensors and actuators in there. There's an edge cloud processing information in real time, is guiding the robot to very precision manufacturing. Yes, we had it already, but there's one problem. Actually, I had two problems in that figure. First problem is there's no human in there. So we're kind of building something which was really designed for machines. We're building essentially technology which would empower machines. We didn't really build technology which empower humans, and that's really what I wanted to do. I wanted to amplify your skills. If you're skilled in something, in painting as shown here, I want you to be able to teach that across the planet, right? So this human 4.0, as I called this, was really missing, and it's a substantial departure from the Industry 4.0 thinking. The second problem with the figure is that actually there's no internet there. It's an intranet. So if you look at Industry 4.0 manufacturing, digital transformation thinking, it is always a sensor in the manufacturing hall transmitting data to a cloud center, which is at the edge, so very close to the manufacturing hall, if not even in the manufacturing hall. It is doing the processing and then almost in real time firing back the instructions to the robots, right? So what you're doing is you're building an intranet. This is not a manufacturing hall, you know, talking to a supercomputer center on the other side of the planet. This is literally a very close geographic proximity. So essentially what we're building is an intranet, a local area network for the purpose of Industry 4.0. So I wanted to depart from these two things. I wanted to build something for humans, and I wanted to have a true internet, because it's the true internet which gives us that disruptive capability the internet has given us today. So we embarked on the, on the design of that, and it is essentially, something which the internet has gone through already. And I looked at the internet evolution over the last 40 years, and 40 years back, we started with proprietary technology, and everything was circuit switched. So in essence, if you wanted to make a video call, you could do that, but you had to use on both ends the same camera technology, the same kind of company. So it was Siemens to Siemens, okay? So that type of technology would work 40 years ago over a really shitty network. It wasn't even circuit switched, it was a hand switched often, right? And then we as a community went out and kind of disrupted the field for 40 years. A lot of stuff happened, but the two things which are worth outlining is we invented IP. So IP is the language which is spoken by every single machine today. And as long as your machine speaks IP, it can talk to any other machine. So if my small sensor speaks IP, then it is able to communicate to a supercomputer center in Australia, right? So it's all possible. And that kind of universal language was a real disruptor in design. And the other thing we did is, which people forgot, is we designed codecs, right? So a codec is a standardized way of compressing, transmitting, and decompressing information. And video codecs today allow me to take a video on my iPhone, right, and play it on my Dell computer. We couldn't do that 20, 30 years ago. So therefore, the introduction of IP and of the codecs was a real game changer to the internet as we know it today. Now, in the Internet of Skills, we are the same starting position as we were with the internet 40 years back. We do have Internet of Skills devices today. We do have devices where we can execute touch and robotic movement over distance. Now, the distance isn't very large, and the system is super proprietary, and it's bloody expensive. And one of them is shown here. It's a Da Vinci robotic surgery device, costs more than $1 million. But the doctor is actually not operating with the patient. It is operating at a haptic device, which is transmitting the muscle movement of the surgeon into robotic movements, and therefore the surgeon is able to operate the patient, which is often, not very far, 5 meters, and it has a lot of medical attention around this. But we have decoupled essentially the skill set. So that's very important. Now, if I look at this, it's there, it's expensive, it's proprietary. What we need to do is, and I understood that in 2014, is to do two things. Improve the networks, because the network is not good enough, because as the surgeon cuts, the surgeon needs to feel essentially that he or she is coming close to an artery. Because if he or she doesn't know that, it is potentially cutting through. Now, I'm not a doctor, but we all understand that cutting through an artery is not a good thing, right? So therefore, action and reaction needs to happen within a few milliseconds. You can do that over 5 meters. You can do that maybe over 100 meters. But how do you do that globally at an internet scale? That was a big challenge, right? So how do you make this globally over the internet globally? So that's challenge number one. The networks needed to be rethought. Challenge number two is to introduce codecs. We simply needed MP3s for touch, right? MP3 for muscle movement. The last thing we wanted is that Siemens and ABB and all these companies invented their own kind of codecs, and it wouldn't work across the board. So we needed a standard here, which I co-founded as part of the IEEE initiative. So we're currently designing these MP3s for touch and muscle movement. So I figured if we have these two constituents, we can really get this up and going. We can really build an internet which allows us to essentially transmit skills remotely. So we encountered a few challenges on the way, and I thought I will just share these challenges with you. So challenge number one is really the delay challenge. You have figured this out. You know, there's something which doesn't work. Mischa, you're telling us some bullshit here in terms of the latency. It's impossible that you have a few milliseconds from London to Sydney or to Los Angeles. And you're right? So if you look at this, I broke this down for you. What we really want is to have all the latency within 10 milliseconds. So why is that important? Because our human brain can be cheated within 10 milliseconds. Everything which comes into my vortex within 10 milliseconds is perceived as instantaneous. And this gives us this feeling of immediacy, right? So you know I am not with you because I am definitely more than 10 milliseconds separated from you. But you know, if I stood in front of you, the optical signal would travel into your eyes, would be processed by your vortex very quickly, and you would have that feeling of immediacy. Now, that is one of the reasons why the eyes, interestingly, are very close to the brain, because our nerves are very slow. So the time it takes from me touching the end of my finger, traveling through all my arm up to my brain, is about 120 milliseconds. And you know that if you touch a surface, which is very hot, but you don't know it's hot, right? So if you don't know it's hot, you touch it, you don't feel that immediately. That delay is because it's so slow. So therefore, my eyes are connected with one single nerve straight into the brain to give us that latency advantage. Anyway, I diverted a little bit here. So we really need to get everything down to 10 milliseconds. Well, I showed you London and Los Angeles. I work a bit with LA here. So how do we do this? Well, if you look at it, you look at these boxes here. So let's start with the green one. So it turns out it takes a lot of time to compress and decompress your audio and video, anything between 60 to 120 milliseconds. So just the time it takes for your mobile phone or for our Zoom app to compress the video and audio and then to decompress it on your end, wow, 60 to 120 milliseconds are gone. That's precious latency. So we have a problem here, Watson, right? So the next one we had was networks. So the networks are quite lousy these days because they are best effort networks. So it takes about, 50% of my time to get out of London and 50% to get back into, Los Angeles from all that networking delay. The reason is because the routers in metropolitan areas are overloaded, particularly during peak time. So you get a huge network delay simply because packets are waiting in the queue of the switches and of the routers. And then you have something which is really annoying. Oh my God, speed of light. What do we do with that? 36 milliseconds. And, to my fairness, I went to the physics department at King's College London, and I asked them whether this is really fundamental. Is it something we need to live with? And they confirmed that in our current universe, I'm afraid, speed of light is a fairly constant, and therefore cannot be tampered with. So therefore, what do? We have a gigantic delay from London to Los Angeles. We need to squeeze it down to 10 milliseconds. Now, I could spend another 2 hours telling you how we do it, but let me just show you the magic here. So the magic is no magic. So to get rid of the application delay, we don't compress. Okay, so we don't do any audio compression. We don't do any video compression. It goes straight from the LCD display through the network out onto your screen. So that saves us a significant time, actually, really significant time. But of course, you understand what before was a 10 megabit stream is now 100 megabit per second stream. What before was a 1 gigabit per second virtual reality stream suddenly becomes a 10 gigabit per second reality stream. So therefore, we have a trade-off here in terms of latency and bandwidth. And I challenge you to find a really good kind of trade-off on that Pareto curve to be able to kind of save our network bandwidth, but also give a low latency. So it's an open problem for you maybe as PhD students. Now, how do we get rid of the yellow boxes? We introduced softwareization, we introduced 5G, and we can introduce slices. These are highways which guide your packet straight from London to Los Angeles and back. And when a packet hits a router, the router would know this is an important packet. I need to let it through. It's part of my slicing architecture, and therefore we get rid of these 5 yellow boxes. This is what my community, the telco and the networking community, has been doing in the last 10 to 20 years, right? So just getting rid of these yellow boxes. But we are 2020, we are there, we can do that today. Now, how do we deal with artificial intelligence, with the speed of light? So we introduce AI. Now, what we're doing is we are predicting essentially what the other environment would do. So if I'm the master, I'm the surgeon, and I'm cutting essentially tissue in Los Angeles, my AI would try to predict how the surgeon would do the cutting operation. Now, we are all, when it comes to human skill, we are all animals of repetition, meaning we do it all fairly, fairly repetitive. The way I wave my hands, the way I play the piano, the way how I speak is fairly repetitive Mischa tasks. So if I have an AI which is trained on me, it would know essentially on how to do the prediction. And the prediction doesn't have to be done over minutes, not even, over seconds. It just has to be a few tens of milliseconds. And there's a whole field behind, a scientific field called model-mediated teleoperation presence, which essentially is doing that and is used in gaming today. So if you play Fortnite and you play with somebody, in Australia, to compensate for that latency delay, a lot of predictive AI is being used. So you have this feeling of real-time immediacy. So this is how we did it. As I said, I could spend probably more hours on that. Just look at my publications we did with my team on that. Quite exciting. So let's move on to the next challenge we found was everything around AI. And it's, we just felt like we opened the Pandora box here. And, I don't want to talk you through, all that field of AI right now, whether that is part of a, more machine learning part or deep learning ANNs, CNNs, RNNs, whether you GANs, LSMTs, you will know that stuff. There's a lot. What I want to talk about is the more fundamental things around AI. And we do have a problem, Watson, here again, and that is what my buddies in Oxford have summarized as the paperclip conundrum. So the issue really is that imagine the year 2030 or 2040 or 50, whatever, and we have this really peaceful AI, which is now prevalent around the whole planet, and it's being tasked to essentially manufacture a paperclip to every single human on the planet. So we have 8 billion people on the planet, and the machine starts yielding the metal, starts doing the paper clips, starts posting that, and it kind of gets to 4 billion, 5 billion people, and then suddenly it runs out of metal, so it can't yield more metal. It's just run out of that. So it is kind of thinking, oh shit, I've been tasked to provide these paper clips. I can't do it. What do I do? Well, let me kill the remaining 3-4 billion people, and then I have essentially accomplished my task, right? So it's a very extreme example, but you get the idea. In a hyper-connected world, where we instruct an artificial intelligence to do something which is potentially, very, which has no malice, is a very peaceful application, but because it is connected, hyper-connected, and we haven't thought of all the scenarios which can fall out of this hyper-connectivity, it could potentially cause a lot of harm. So therefore, we started thinking more seriously about this from a policy point of view, and GDPR Article 13 actually interestingly contains a clause which says whenever you use AI in a consumer-facing scenarios, meaning your AI makes a recommendation which film to use, makes a recommendation on what type of dentist to choose. It makes certain decisions on how to conduct certain parts of an operation or whatever. You need to be able to explain why the machine came to that conclusion. And that's a problem. So anybody who has come up, has worked with CNNs, deep learning, all the hidden layers, can you tell, an auditor why your AI has actually taken this decision versus that decision? You cannot, all right? You just cannot. So therefore, we're hitting here a little bit of a black swan scenario, which I don't think many people have really thought through. But there's new stuff coming. So there's new AI coming. There's explainable AI planning coming, which was pioneered at King's College in London, used by industries today, used in the Mars rover mission of NASA. So, there's new forms of AI which are coming along, which help with that conundrum. But just wanted you as students and academics to be really pivot to this type of problem. What's the other thing? A big challenge is to kind of go from this hard robotics to soft robotics. So we have done a lot with hard robotics, shadow companies. So there's a lot of stuff being happening at the moment, which is, developing really cool hard robotic applications. But soft robotics is what really will drive this human machine teaming. This Internet of Skills cannot happen if you have a hard device moving at 50 revolutions per minute, because it will kill you basically. So we need more soft stuff here. And there's a lot of stuff happening at the moment. I'll show you Eckhard Steinbach. He's worked quite a bit on this. Out of this came a lot of the kind of codec work I'd alluded to, and as part of the haptic codec development in the IEEE standards group here, you're welcome to join. We have essentially, advancing these haptic codecs in the kinesthetic codecs. But we need to have more work on that. So we need to essentially be able to execute more thought leadership on soft robotics. So essentially, it is telecoms. Latency stuff was a big challenge. It is everything around AI and everything around soft robotics. All right. Let me just talk to my dog here. She's barking. 1 second. So, come here. So, so she just came back from a walk, so she's a bit crazy at the moment. So when she calms down, I'll show you my my dog. Anyway, so let's move on, and I show you what we built. So this is my view from the office in London. The church you see here, interestingly. So there you see the House of Parliament and Big Ben, London Eye. The church is where Hans Zimmer recorded the theme for Interstellar. For those musicians on the call, there's a base station you see, which you don't see. So I'm zooming in the courtyard. The squared base stations are basically UK's very first 5G base stations. These were Ericsson hardware, which connected to our software in the basement. And if you look at the servers right now, I'm not sure you can pay attention to this, but these are not purpose-made servers. These are Dell computers. Look at this. These are Dell servers. So we have replaced purpose-made hardware with general purpose software, which are my Dell servers, which I could buy on High Street, right? So that is a fundamental transformation in telecom, something which before were kind of ready-made boxes to something which is general purpose-made hardware. And that allows us now also to be so much quicker in innovation, because before, if you wanted a new feature in, let's say, 3G, the telco operators or the consumer would call the operators would call the vendors, the Ericsson, Nokias, and the Huawei's in the world, and these would say, no problem, we'll do it, right? And then it takes 10 years, and 10 years later, they come back with a new box, which needs to be installed. But now we have decoupled hardware from software. We run on a general purpose, hardware, which you can use in any cloud data center, and we put the magic in software. So that's a big transformation. And we worked on this quite a lot. So we build a lot of infrastructure. You're quicker than me in reading this. I will not talk you through. We build a lot of wireless infrastructure, a lot of supporting infrastructure. But of course, you also need an operating system on top, right? And that operating system in the telco world is called orchestration software. So we have two families. We have worked quite with open source Mono, but we've also used the other orchestration frameworks, ONAP specifically, which is very memory intensive, but very operational, came out of the Linux Foundation, AT&T. So I could spend another hour talking about this. But, apart from the technology, we've also been driving a lot of standards initiatives. So you see here, we're founding members and contributing members to quite a few IEEE standards, ETSI standards, and through BT contributed to 3GPP as well, the service architecture too. I spend a good time of my day also with policy discussions on Ofcom, which is our, so I'm on the advisory board of Ofcom, which is our regulator, talking a lot really about this digital transformation at national scale. So that's what it is. So I'm not quite sure who's really on the call, whether you have telco knowledge or not, but I just wanted to show you maybe 2 or 3 things from a more scientific point of view. I won't go into too many details here, so you will see now a little bit of equations. Anybody who's not in telco, do not get scared. This is really just to give you a gist of some of the pioneering work we have done. So the first one was on what is now known as decoupled up and downlink. So something my PhD student and I discovered by total chances is that if you look essentially at the power levels of a macrocell and a microcell, and I'm not sure you can see my cursor, but essentially you see the dotted line here, which is a downlink, and the solid line, which is the uplink. And imagine my mobile phone is very close to the macrocell, so it would be somewhere here. So we have this type of downlink signal and this type of uplink signal. Now imagine I'm very close to a small cell here, which they are more and more in the heterogeneous development in 4G and 5G. I would have this type of uplink and downlink. Now, it turns out that the switch over point between, going from a macrocell to a microcell as you walk along the street is different for uplink and downlink. And we were like, hey, what's going on here? So in other words, as I walk down the street using my mobile phone, and I'm on my macrocell here in Kingston in London, walking along the street, and suddenly, it turns out that my uplink is requesting a handover to a small cell, which I walk into a shopping center as an example, much earlier than my downlink. Right? So we figured out if we decoupled up and the downlink, we would potentially get a substantial savings in, power, in energy consumption, in data rate, in reliability. So there's a lot of stuff we can do. And we started to test this out essentially run simulations. We ran simulations, we did the theory and figured out that indeed, if your up and downlink is decoupled in certain zones, you get massive improvements on reliability. That led into some significant standards work as well, and is now known as a decoupled uplink downlink architecture. So that was pioneered by us, by a wider team. The other thing we pioneered really is to virtualize 5G. So this is stuff we've done, donkeys years back. We have essentially looked at how can you package, the 5G software onto VMs. So VMs are virtual machines. Why do we like VMs? Is because we can ramp them up and down as we like. So if you don't need a certain functionality, then you can just shut down the virtual machine because you don't need it. So you don't pay electricity, you don't pay any cost on that networking cost. So therefore, that whole software thinking, which I alluded to before, needs to be somehow carried out through virtual machines. And the big problem with VMs is, particularly if you work with software packages like VirtualBox and all that, the Oracle software, you essentially realize it's very slow. So how do you get the latency down to the levels we need? So Frank Sardis, who was my chief architect back then, he really came up with super cool solutions, which works quicker than the Linux kernel. So if you look at the latency virtual machine to virtual machine over possibly a 5G network, we were quicker than the Linux kernel, 150 microseconds. So that would take into account a 114 microsecond link, which is essentially, latency in the VMs. And you have a twice forth and back 18 microseconds due to the numerology. We used a very high 3GPP numerology, which you only find in millimeter wave. Putting it all together, we got a virtual machine to virtual machine comms link, which was super stable, very low latency. So really interesting what we pioneered there. The other thing we did is with a wider team was anything around, just ripping apart the whole telco infrastructure. So because currently everything sits either very centralized all together as a monolithic package at the edge. So let's say in a shopping center in Kingston. We said, hey, what if we had the mobility function in, let's take, in London and the actual mobility happening in Edinburgh? Right, so we completely decoupled the functional architecture of 3GPP, not only logically, but also physically. So this distributed neutral host concept is something we have been experimenting for years now, and we actually executed that together with the University of Edinburgh And Frank really was instrumental of doing that within King's College London. So we did all that, pioneered really this whole distributed neutral host from an implementation point of view. Many more things. I don't want to bore you with too much technology. Let's move on to some more exciting things. What do you do with that stuff, right? So people, particularly in my center, folks spend a significant time on the desk doing research, which is quite exciting to some, but others would like to see more. What do we do with that? I call that giving technology a soul, right? So we work a lot on the hard stuff, on the boxes and the software technology, but giving it a soul is something which I think we should be doing more because it's so exciting. What does it mean? It means actually going out to the industries, to the artists, to consumers and ask them, hey, if you had 5G capability or if you had 6G capabilities, that's what I would ask today, what would you do with that, right? And the majority of time you get a blank stare because nobody would even consider that. But I was very tenacious with that. And 2014 is probably the first one who started with that very close co-design around the world, really trying to ask industries, what would you do with 5G if you had 10 millisecond latency, if you had a huge bandwidth, if you had, very flexible edge compute and virtual machines, and now we call that, microservice architecture powered by Lambda functional architectures, things has moved on, but what could you do with that? We asked this to doctors, we asked it to artists, and these are the answers. There's so much more to show you, but I don't have a huge amount of time, so I'll just show you a few of them. So one of that we did is in transport. So we started to engage with the transport ecosystem, TfL, Middlesex University, and we looked at it. And when it comes to 5G, everybody talks about using 5G to do connected cars, to provide safety and all that. And actually, this is all bullshit, really, if you think about it, because the name autonomous cars is actually right? So it doesn't make sense. The regulatory bodies would never, ever allow a car to drive on any streets in the world if it would be reliant on third-party infrastructure such as a 5G connectivity. So I figured very quickly, this is not the story which needs to be told. What I figured out is that if we really go self-driving cars one day, imagine the year 2030, everybody is driving self-driving cars. Well, you don't have that driving experience anymore. Now, anybody who's a driver, that you're really focused on the road. You like it. You like to chase the other drivers. It's a race. It's a race for lanes. It's a race for parking spots. It's war out there on the cities and highways. So therefore, you take this away, people will be bored. What do you do with 4 billion bored drivers, okay? So therefore, we started to work on this concept, what I call office on wheels or living room on wheels. How do you bring the whole entertainment you currently enjoy in your living room or your whole office experience into your driving cars? And this is where 5G is really instrumental. Edge cloud, moving edge cloud and all that. That is the big game changer here, which really people need to think of. So that's what we've been doing for years now. Another really exciting one we did with transport. So Dr. Mahmoudi, my academic colleague here at King's, was driving that. Super exciting, and that really fits into this my vision of the Internet of Skills. So we had this big industrial drone, and it was installed in the courtyard of King's College London. We had to fly in very specific qualified pilots because you need a special license to fly these beasts. So these were guys from France, from Paris. We flew them in. We didn't tell them that the remote control that we're using was not directly connected to the drone. Actually, what was happening is their link went to our base station. It was sliced to Verizon in New York, and it was sliced all the way back with the BT&E network to us, and only then connected to the drone, right? So they were flying the drone. They had the full experience, but their signal actually went to the other side of the world, and they didn't notice a thing. So what I wanted to prove here really is the ability to execute skills very critical skills. Flying drones is critical stuff. You are able to execute it with the right architecture, end-to-end architecture across the planet, no problemo. So if you have a crisis, a national crisis, let's say there's a mudslide somewhere in India, in Africa, we can have the best pilots around the world deliver medicine, deliver food, deliver whatever we need to the people who are affected by that without flying in these pilots. So this is a game changer, and I want you to understand that. What else did we do? Well, we did a medical transformation. So let me play that video. I hope you can hear Proka talking. If not, there's a subtitle.
That's not the way we see medical treatment. If you see an open surgeon operating, they will have a bit of tremor at the ends of their scalpel. The robotic instruments are computerized, so they have absolutely no tremor. There is one problem though. There is no sense of touch at the end of the instruments. It is very difficult to transmit across remote distances and across current robotic systems. In order to do this with haptic feedback technology, you need two things. You need network slicing and you need cloud data share. I think both are possible through 5G.
So I stop it here. The video's on Ericsson. We worked with Ericsson. So I work quite a lot with Ericsson. It's a great company to work with on that. So the thing here is this is Proka, my colleague from King's. King's owns 4 hospitals. He's a practicing surgeon. He spends all his day doing surgery, right? He actually pioneered robotic surgery in the UK. So, and he talks about 5G, edge cloud, slicing. It's amazing, right? So that was a result of us spending, years together really co-designing. This is not of us doing just a workshop of 1 hour, showing some PowerPoints. This is of us actually spending quality time together. Proka was spending a lot of time in our labs. We were in his, when he was actually executing surgical operations to understand what's going on there. So the ability for him to democratize his skill set, essentially be able to execute operations anywhere in the world, and they're currently doing this actually. This video was done 3 years back. They're doing this right now with China. If you're interested, I can connect you. So this is super, super pertinent stuff. And I remember when I introduced that concept of remote surgery or remote medical intervention at the Mobile World Congress in 2016, I got a lot of shitty press, like really shitty press, and then, 2 years, 3 years later, God, I always say, is very quick these days. Everybody latches on that because I worked with the people who would use it. I didn't make this up as a techie. I made this up as a community of a doctor and a techie, and I knew this would fly. So today we're able to do that. Very low latency. He can transmit the skills. Proka lives in North London. He doesn't have to commute. This is what type of stuff he can do. We gave him back this feeling of touch, which he also didn't have. So a lot of pioneering work actually, which has happened on this slide alone. And we have pushed it then further with, Hongbin Leo, another colleague of mine, and George Abrams. They pioneered a lot. These are robotics guys. They pioneered a lot of soft robotics and miniaturization, and particularly useful for colonoscopy. So colonoscopy is something which is, if that is not done early enough, you can cause colon cancer isn't detected early enough. And the problem is many nations, every nation, UK, whether it's UK, India, Australia, Finland, the problem is the high-end hospitals are in the capitals. So people, in the rural areas do not enjoy the very same medical attention. And colon cancer is one of those cancers which develops slowly, and once you have passed the threshold, it's too late. So therefore, the ability to have an intervention early with a high-end medical skill set is very important. So together with Ericsson and China Mobile, we're currently building probably the very first 5G remote kind of Internet of Skills operation in China, which will save lives, where we have a very cheap outlet in the rural area in China using ultra low latency connecting to the hospitals in Shanghai, Guangzhou to really save lives there. So this is up and running. Very, very fascinating work where we combine medicine with telecoms, with computer science, and with robotics. What else? I work quite a bit with artists. So, I'm not sure you read my bio. I'm half artist myself. I want to become a professional pianist, publishing quite a few albums I'm composing. So working with Rob here. Rob is the founding member of Massive Attack, and maybe you know Massive Attack. I'm not sure what age group you're in, but anyway, Rob is a great painter as well. And we asked a very simple question: could essentially a robot paint with him in real time? He's in his studio in Bristol, and we're using 5G technology with some edge cloud to understand what he's painting, and that is then being retransmitted to another robot, which is painting with him. So that has been covered by the Wired magazine. You just Google for that, you will find it really, really fascinating work combining again the arts, technology, computer vision, and robotics. Another thing we did with Los Angeles, so the guy you see, not this guy, the other guy you saw is Peter Gold. He is #2 DJ in the world after Deadmau5. I'm not sure how much into clubbing. I suspect you can't go dancing a lot these days. But essentially, we had him projected on a hologram. He was DJing in Avalon, which is a big club in Los Angeles. We connected him to an adjacent club in West Hollywood, projected him on a hologram. And of course, you don't need 5G technology to do that because it's only one way. Where you need 5G is where you actually project the dancing crowd back to Peter. So he had to adjust the BPMs, the beats per minute of his music, to both the crowd he saw in front of him, as well as the crowd which came digitally in from the West Hollywood club. And that became a very big challenge. It's a control loop challenge. Again, anything below 10 milliseconds needs to go. And I realized actually what we do is going beyond, holographic reality or augmented reality, virtual reality. What I was building here is a new thing. I gave it a name. I called it synchronized reality, because we are really synchronizing different realities, 2 or 3 realities. That's what 5G can do with this level of immediacy. So it's quite an exciting development really here. So take this away, I think 5G and all that can really deliver this synchronized reality. What else? Something else, if you are a Massive Attack fan and you happen to have been to his concerts, you will have seen some of these GANs working their magic on screen, on stage. And these were actually rendered on my infrastructure using Mario Klingman's AI. So again, we used cloud technology to make it happen. So combining arts, actually production. So this was went into the real concert. I accompanied Rob to his Paris concert last year or 2 years back already. Oh my God, time is flying. In his London concert. So this has been used as part of his concerts. Another thing which my good buddy Zoran does. So Zoran is actually a professor in signal processing. So we got him from Stanford University, was in Berkeley. He pioneered a lot around OFDM, which we are using as part of our telco stack, but he works now on sound. So he created this real-time capability of building aural spheres. So essentially, being able to reproduce any sound field such that you have the impression it's in a church or in your living room or in any type of scattered environments, really useful for games. But he also started to work with artists like Zhuzha Wang. So if you're a pianist, you will know she's the #1 female pianist. Reep Swan is world's #1 beatboxer. So they were recording this technology. This is now being processed on cloud in real time, and you can create these soundscapes essentially on the run. So really trying to give, as I said, technology some soul here. And I'm going to finish with my last slide really, and that is a very personal slide. And I just want to, let's play that and then I will finish off. Okay, so I'm not sure you know this song. So, normally if I'd be live in front of you, I would query you. But some of you may know, so the original song is a Kiss song from the rock band Kiss. Very rocky song, really. It was made. It's called "I Was Made for Loving You." And then Maria Mena, I think she's from Iceland, an Icelandic singer. Or maybe she's Finnish. I don't know actually. She did cover on that, a guitar cover, really beautiful. So I did a piano cover on that. And what happened is I was in Berlin, right? I was in Berlin under the Brandenburger Tor playing the piano. And the lady you see there the young lady was in London. She was on, in the Guildhall. And the Guildhall is a very historic kind of built or venue close to St. Paul's Cathedral. And it's UK's oldest entertainment venue. So the Romans brought that 2,000 years back into the UK. And so we thought of combining ultra latest technology with very historic type of, kind of venue. And we put Noah there. So Noah, we're very privileged to have her. So she sings, before the crisis, she sang quite a lot in the Royal Opera House. She also sang with Madonna. If you're into Madonna, she sang on Madame X on a few songs. Madonna released an album last June, so she was on there. And incidentally, now not wanting to show off too much, incidentally, she is also my daughter, right? So she's my older daughter, and we were able to practice a lot. But we were able on this evening to actually connect to a level of immediacy which I did not expect. So we had done quite a bit of, Skype sessions, and you probably, if you're a musician, have done a bit of Skype and Zoom, but you always feel the other musician is very far. Now, with our 5G technology, very low latency codecs, which were developed by Alex, a friend of mine in Germany, put it all together. Suddenly, we had an ultra low latency system, which brought Noah and me together, even though we were 1,000 kilometers separate. And it was so emotional that whilst I was playing, I really struggled not to cry that night, because it really felt Noah was just next door to me, okay? So this is one of the really amazing features of technology coming, and I thought I gave you a good overview what we can do with 5G, what's my vision around this Internet of Skills and 5G, how it fits in there, and really how the future looks like. And the one thing I really want you to take away with, don't shy away from combining your tech world with what I call this giving the technology some soul. I leave you with that. And I'm not sure what questions are planned, but that's the end of my presentation. Thanks so much. If you're in London after the crisis, come and visit me. Not all at once, of course, but this is the view from my office from Bush House. So I'll leave it with that. I stop sharing now, and thanks for your attention. Yeah, so I'm being asked if I'll take questions. Yeah, I can take questions. Happy to do that. I blocked until about 1 o'clock, which is when my wife comes down and my daughter, and they will be wanting some food. So very happy. I can't hear you. Somebody's speaking. So somebody saying cheers from Melbourne. Pleasure. I was actually today in the morning, I did the keynote for the UK Australian Chamber of Commerce. So I was connected with Australia as well. My company one of my companies moved there. So guys, if you have questions, I'm happy to take them now. I'm not sure what the protocol is, if you're allowed to actually speak, or if you need to actually into the chat. So I'm just seeing, did you have a role in Amazon's uploaded? No, I didn't. Okay. Any other questions? Anything you guys would like to get answered? If not, we call it a day. And you can go for lunch, and so can I. Yeah, you can post in the chat. I'll wait a bit, so I'll be very patient here. So what's the general background? So my email address is and I'm not super quick on email because I get quite a sorry, I need to send this to everybody. Okay, my email is Mischa Dohler, KCL, ICUK. Okay, and I'm much quicker on WhatsApp. So if you want to send me a WhatsApp, you can do that as well. Right, so here you go. I hope this has gone out. Yeah, okay. So guys, is your background all in telecoms, or do we have some outliers, some people not working necessarily in telecoms? I know this is called a 5G hackathon, but very keen to understand, what's the background? Anybody in social sciences or computer science, or maybe robotics? What are you guys up to? All right, Stephen, robotics and IT, very exciting. Melbourne, Philip is high school students. So I hope you're going to join one of the universities there. You've got quite a few good universities in Melbourne. So very different backgrounds. Okay, that's good. That's the right thing to get the hackathon going and get this cross-fertilization going, right? So solving climate change, brilliant. ICT, ISK and Turco, very good. Security is great. Forestry management, now this is so cool. Smart cities, brilliant. Yeah, okay, so there's cryptography, great stuff. So it's a really good mix here, guys. So, you should definitely spend a good time together. The question of Vinet, who asked a good question on 5G. I have a very broad background as well. So I not only do tech companies and tech stuff, I also have, entertainment and a media company. I do a lot on education. So I have a 5G course company as well. But also one on, now don't laugh now, right? So I have one on coffee. So we're doing Nespresso compatible coffee pots, but they are biodegradable, right? So I co-founded this with a material scientist from UCL and somebody who's really good in synchrotron radiation and all this kind of innovation stuff. And we started this company, and because I see people now is really on not only on innovation, tech innovation, but also on sustainability. So that's a company we started as going really well. So if you guys are running out movingbeans.com, you happen to be in we open movingbeans.com.au for all our Australian friends down there. So let me come now to the question which we need asked about the implementation of 5G. Yeah, so as you can imagine, it's quite a long transformation for operators to really buy into this fully softwareized type of, for the softwareized infrastructure. So it will take time, okay? Indeed, so we need refers to three acronyms, which I haven't talked about at all. But the first one is EMBB. It stands for Enhanced Mobile Broadband. So this is essentially a 4G++ in terms of data rate. So going from what you have probably now an average 10 megabits per second on 4G in average, I'm saying, okay, 10 megabits per second to 100 megabits per second on 5G. So indeed, this will probably be the very first use case. And the reason is because that use case can be supported without having a 5G core network fully functioning on its own. We call it standalone core network functionality. What we do is with EMBBs, we would anchor it into a 4G network. So it's only the wireless interface from your mobile phone to the base station, which would use partly 4G and partly 5G, but then in the back end on the core network would actually use 4G, okay? So you can do the broadband through the interface, but you can't do the sexy stuff like URLCC, which I'll come to in a moment. Now, URLCC stands for ultra reliable low latency communications. And for that, it's really this 10 millisecond type of, or even 1 millisecond type of execution. You need a 5G core network. So we need to wait for a transition to happen from something which is a hybrid 4G, 5G to a truly 5G system, right? So, and we call that the transition from, 3GPP, and the ITU has options called option 3 to option 7. That's what we need to do essentially. And that's a very industry specific answer. And it will take a while. So some countries will do it quicker. Particular Asian countries probably will execute this really, really quickly. I know that China is fully on it, Japan and South Korea. Some operators in the United States, Europe hopefully will catch up very, very quickly. We'll see how it goes, but it will take time. So I think, really large scale deployment 5G, so you can build a business on that. It will take another 5 years, sadly, We have 5G in the UK, so we have it now across all our 4 operators, and it will take, so we have it today in hotspots in London. I can use it on my 5G phone, no problemo. But as I go out into the rural areas and to some other cities, I cannot. So therefore, 2 years to get it kind of adopted, early adopted, good coverage, 5 years to get it really up and running. And hopefully in 10 years time, we're gonna have 6G, and hopefully you're gonna get rid of the whole notion of G. So I have a whole other keynote on can we get rid of this notion of G. Anyway, I'll leave it with that. I'm not sure if you have any other questions. If not, very happy to call it a day. You guys have been a great audience, even though I haven't met everybody here. Nikolai Krupin says he has been a transport engineer. That's great. All right. Okay. So my hosts are taking over now. Guys, fantastic meeting you. I hope you enjoyed that. And I'm happy to share the slides with the PDF version of the slides with the organizers, and you just take it from there, okay? Stay safe, stay strong, disrupt the world, and be kind, okay? See you later. Bye.
Thank you, Mischa Dohler, for an interesting lecture. Day 9 is now coming to its end, and tomorrow is time for final pitches. We will send you the wrap-up email and inform you about few important matters of the lecture. Thank you, and see you tomorrow.